Hey there, welcome. Have you ever stopped and wondered what's really going on inside that phone in your hand or the laptop on your desk? These devices are a huge part of our lives, but they kind of have this secret life, right? Well, today, we're going to pull back the curtain and take a peek inside the digital mind. We'll start with the biggest question of all.
And really, it all boils down to this one question. How on earth does a simple box of circuits and wires understand something as basic as a mouse click or as complicated as a piece of software? Well, you might be surprised to hear that the answer is actually, believe it or not, beautifully simple. You see, to get what a computer is doing, you first got to learn its language. And this isn't a language of words or letters. Nope, it's a language made of signals. Tiny electrical messages zipping around, carrying all the information. So at the very heart of it all, you've got two kinds of signals. First, there's analog. Think of it like a smooth, continuous wave, kind of like the sound of my voice. The problem is it can get messy and distorted by noise really easily. But then you have digital signals. These use separate, distinct values. It's either one thing or another, on or off. This makes them way more resistant to any kind of interference, which is perfect for the kind of precision a computer needs. And here it is. This is the secret sauce. Every single piece of digital information, I'm talking about your favorite song, a high-def movie, the most complex video game, it all gets broken down into a long sequence of just two numbers, 0 and 1. That's it. This is called the binary system, and it's the simple, powerful alphabet for the entire digital world.
Okay, so the computer has its language of zeros and ones. But how does it actually think in that language? Well, that brings us to the hardware. And we're starting with the electronic brain itself.
So take a look at this. This is basically the blueprint for every single computer out there. It's a simple flow. You give it some data through an input, like your keyboard or mouse. That data zips over to the central processing unit and memory. That's where all the heavy lifting happens. And finally, the result gets sent to an output device like your monitor. Input, process, output. It's a simple loop, but it's incredibly powerful.
And right in the middle of it all, you've got the CPU. This thing is the brain of the whole operation. Seriously. Just like our brain, it's in charge of everything. It's where all the math happens, all the logical decisions get made. It's what takes those streams of zeros and ones and actually turns them into things happening on your screen. Without a CPU, a computer is just a box of parts. Now for that big brain, the CPU, to get any work done, it needs two things: a place to work and a place to store its stuff long term. And this is where we have to understand the huge difference between memory and storage. The best way to think about it is like a workspace versus a filing cabinet.
First up, you've got primary memory, which you probably know as RAM. Think of this as the computer's desk. It's a super fast but temporary workspace. It's where the CPU keeps all the files and data for the apps that you have open right now. But, and this is key, it's a temporary desk. Once you shut off the power, poof, the desk is cleared. We call that being volatile.
Then you have secondary memory, or what we all just call storage. And yep, you guessed it, this is the filing cabinet. This is the permanent home for your operating system, your apps, your photos, all your important documents. It's non-volatile, which is just a fancy way of saying your data is safe and sound even when the computer is off.
So let's just put it all together, side by side. RAM, your workspace, is incredibly fast, but it's temporary or volatile, and you only have so much of it. Storage, your filing cabinet, is slower, but it's permanent, non-volatile, and it can hold huge amounts of data. Your computer absolutely needs both of them working together to function.
For a long time, this was our filing cabinet, the hard disk drive, or HDD. And honestly, it's a mechanical wonder. You've got these platters spinning thousands of times a minute, and a tiny little arm that reads and writes data magnetically. But all those moving parts mean it's slower and a bit more fragile. But today, things are different. Most new computers have what's called a solid-state drive, or SSD. These use flash memory. It's the same kind of tech that's in a USB drive. And because there are no moving parts, they are way faster, way more durable, and they use less power. It's a total game changer for storage.
So how in the world did we get here? How did we go from these giant calculators that filled up entire rooms to the sleek little gadgets we carry around today? Well, it has been one heck of a fast and wild ride through 5 distinct generations of tech.
The speed of this is just mind-blowing.
The first generation ran on huge, hot vacuum tubes. Then, the second generation brought us the transistor, making computers way smaller and more reliable. The third gave us integrated circuits, which packed tons of transistors onto one tiny chip. Then the fourth gen delivered the microprocessor, a whole CPU on a single piece of silicon, and that's what gave us the personal computer. And now, here we are in the fifth generation, focused on things like AI and processing tons of data all at once.
And all of that history, all those building blocks we talked about, the input, the processing, the output, they've exploded into this incredible variety of computers that are, well, literally all around us.
I mean, just think about it for a second. That same core blueprint applies to all of these, from massive supercomputers predicting the weather, to your desktop PC, to the little chip in your smartwatch or smart thermostat, and yeah, even to that incredibly powerful computer you carry in your pocket, your smartphone. They all have a brain, a workspace, a filing cabinet, and ways to get info in and out.
When you really step back and look at the whole picture, the progress is just staggering. We went from a machine that filled a whole room to an assistant that fits in the palm of your hand, all within a single human lifetime. The pace is absolutely breathtaking, and it leaves us with one final, really exciting question. What comes next?